future hand in hand in this tech-driven wonderland.
Hello, everyone. Welcome back to Near AI Office Hours. Today with me, Alex and Eric. All of us are making really good progress on Near AI, and today we want to go over the different topics we're working on, as well as outline kind of how all of this fits together, and obviously invite you to contribute and participate in what we're building. So maybe before we go into what we're doing, we're gonna talk about why we're doing it and kind of how we believe future will look like. So the first part is we believe that AI is going to be a fundamental shift in how every single interaction with computers, internet, and even economy as a whole is going to work. And through that, a lot of the kind of small things, like how you're ordering things, how you're deciding on where to go, etc., will change. But also big things, how even governments and industries are run, because AI can not just kind of automate some processes, but actually start making decisions and go from kind of this traditional process where we usually delegate decision making to other people and companies. Now you can have decision making happening on your side, personalized for you, given all of the information around the world and all of the other participants around the world. So how do we get there, right? This world is, pretty complex right now, and there will be a lot of kind of transition period before we get to that future. And so the first step is what we call AI assistant. So I'll let Eric kind of dive into that.
Sure. Thanks. So really trying to envision what your interaction with the internet's going to look like in the future. And so we think basically there's going to be same sort of thing you see in sci-fi. There's going to be an assistant sort of works for you, knows everything it can about you, knows your preferences, knows your general needs, knows your information, knows your history. And when you need something or you want something, whether that's like, hey, I want to replace a broken mug in my house, or just give me some content to scroll through, or tell me today's news, or every week make sure that I wake up tomorrow on time, like it will figure out how to do that and give you an answer. We expect that like the world of individual apps will kind of just fade away over time. So that assistant can be great, but it won't be able to do everything by itself. It's going to know as much as possible about you, but it won't know as much as everything about what it can go and accomplish. In order to do that, it's going to have to talk to other AIs. That's what we call service agents. Basically, your AI assistant represents you. It's going out there on the internet or in the real world, they're helping things happen in the real world for you. In order to accomplish those things, it has to go communicate with other AI systems that will represent either other people, other services, businesses, what have you. And those will help you get something done. What's that? A factory. Oh, great. So each of these ends up being a service agent, which could just be somebody else's assistant, really. It's just a matter of when you're it's a matter of point of view. In order to figure out how it's going to get something done, we have a third category of AI agent we envision that we call a discovery agent. That's something that the assistant can give a more general sort of intent to. I'd like to accomplish this thing. I'd like this information. I don't have it myself. Can you either go out and find it for me by understanding the directory of all the service agents out there and just going querying for one, or perhaps broadcasting to an area of like, hey, my user needs something done. Who can help me? Or just sort of introducing your assistant to an agent that can go solve the problem.
Maybe just to run a specific example or a few specific examples, right? And kind of show the breadth of this, right? This can be something where, hey, I want, to buy a sleep tracker, right? And right now you would, Google then maybe you go to Amazon, then you maybe, like in my case, would Google again, because you're like, well, I don't trust Amazon reviews, so I'm gonna go check between a few different products which one like people reviewed. And so you kind of go in that process, right? And so you can imagine, the same thing. Well, first of all, your AI assistant probably knows that you don't sleep very well, so it already predicts that you need a sleep tracker. And to improve this, to get more information about you and recommend you, different sleeping patterns. So it can issue this query, okay, I need a sleep tracker. Like, who are actually selling this kind of equipment? The discovery agent, knows about 2 different stores. So it either like introduces you to them, and so you can connect to them directly, say, hey, I'm looking for a sleep tracker. One of them is responding, hey, this is the one, this is how much it's going to cost. Maybe you also got some review agents, or maybe you actually just your AI assistant get connected to somebody else's AI assistant who is kind of similar profile, who you effectively getting like feedback as well about the sleep tracker you considering buying. This also works in cases where, for example, you're actually in a professional setting and you're trying to accomplish some task, for example, run a marketing campaign, hire someone. Again, you can go, you say, hey, I'm planning to run this marketing campaign. I want somebody to do this for me. It knows few different marketing agents who then give you quotes on how much this marketing campaign would cost, how would they run it. Your AI assistant evaluates it, either decides directly or asks you to choose from one of the options. So it's a pretty versatile kind of system that can go from your kind of basic needs, food and shelter, to more advanced things, to business cases and kind of global commerce as well.
What connects all these little boxes is that they are all AI agents, and that's a word that everybody in the world, at least in the AI space, is using, and nobody has the same definition for, so we're going to give it another shot. What we mean by agents in this context is that they are services backed by AI inference that can be talked to. Now, in this case of the assistant, it's generally the user that's talking to that agent. In the case of discovery here, it's usually your assistant that's talking to it. You could also go talk to it directly, but mostly your assistant's going to be doing that. Same thing goes for these service agents backed by services. Your assistant will talk to them. You could skip it, but we think in the future, you're mostly going to be mediating your interactions with the rest of the internet through this assistant. As opposed to what you see a lot of development right now is in things that are called agents, but they're really a template for an agent to interact with some existing service, some real world, some website. And that's an important component of this system, but it doesn't really make an agent that you can go talk to in natural language, or whether that's video, audio, text, what have you. I mean, the modality of it doesn't particularly matter here. Nor is this one masterful, amazing thing that does everything. We imagine that there would be multiple competing AI assistants competing for which one is better, multiple discovery agents competing for which is better at matching your intent to a solution. Of course, multiple service agents. This is just the economy of the future internet. What we're trying to build here is how we're going to make this happen. And to be clear, this is not necessarily that we believe that this won't happen if we don't do it. We think this is inevitable, and we're going to try to make sure that it doesn't suck by building this on open protocols, decentralized infrastructure, user-owned models, so that when this happens, it's not going to end up as basically the AOLification of the internet. Again, I think this model is going to be the future. If we don't do anything about it, and say OpenAI builds this whole infrastructure, then they get to kind of curate what the whole internet looks like for you. It ends up being, they end up being a gatekeeper. They can decide what information the models use. They can decide how the discovery is going to work. If we build this as an open protocol and get enough people on it, enough users coming in, enough service agents, a competitive discovery system, then we can build something that's a lot more functional and let the open world sort of swallow the curated world. You know that?
Yeah. So now the question is, okay, what is the protocol effectively that connects all those things, right? Because I mean, you can imagine this can be running on an open infrastructure, which is what we're really pursuing. It can also still be running on closed infrastructure. We just want it to be connected into one protocol. And so this is where we're really kind of proposing this protocol called AITP. It's Agent Interaction and Transaction Protocol, to allow us to really interconnect all of these agents in kind of structured format and open up ways to pay, to transact, to share credentials, to share information, to share kind of state and sessions between all of these different participants of the protocol. Let's
the controller or something.
Yeah. So what is required here, right? Well, there is kind of a fundamental piece of data that is needed. Okay. So what do we need to actually achieve this? Well, we need a fundamental kind of object that everybody will share and is able to interact with. And so we actually are taking on an API that already pretty widely used for AI assistance by OpenAI, and it's effectively a thread API. And so thread is right now effectively a chat history between few different actors, right? This can be user, this can be another agent, multiple agents, and this can be some tools calling and a bunch of other stuff. And so the idea here is we want to add more kind of structure, kind of optionality to allow for various interactions. And we want to allow this thread to be, again, not a centralized thread where you need to go to only one service and only through that service you can interact with it, which is kind of current state across the industry, but actually a thread that multiple different participants can actually share, interact with, join, leave, add somebody else. And so make it effectively similar to how email works, right? You can imagine, right now you're effectively going to OpenAI and you're talking to OpenAI kind of model or agents or Claude or any other system, or kind of this new system where your AI assistant effectively creates a thread with a discovery agent. Discovery agent can add another agent to the thread and maybe remove itself, put it in BCC and kind of continue, continue conversation with the new agent. So very similar to kind of email protocol, and now we're adding a set of properties to it to expand it.
Yep. So, I mean, it's a pretty simple idea for a protocol. It just sort of standardizes how an agent is going to be able to talk to an agent in the same way that a user can talk directly to an agent. And what are the standard capabilities that an agent needs when talking to another agent in this format? One of the for a lot of stuff, like you can talk over natural language, again, whether that's text, voice, image, what have you, and that'll work fine. But there are places where you want to drop into structured data, where you want to make sure that you're getting exactly things correctly. A couple big examples of that. One big example of that is payments. If you're going to buy something from this factory, you want to make sure you're paying exactly the right amount for exactly the right product, that you've that it's agreed upon what you're going to get, what the terms of that payment are, what the return policy is, what the payment method is supposed to be. And so we're designing, again, open standard and protocol for how any agent can go request a payment from the agent, from whoever's talking to it, which essentially is just going to be a tool call, if you're familiar with LLM parlance here. So on this thread, we're going to pass back a tool call to say something like a request for payment. Now the AI assistant there can, if it is authorized to do so, if it has the means to do so, it can do that payment. It can respond to that tool call, go and pay for the thing. It also can sort of pass it further up chain. Okay, maybe I'm not authorized. Maybe I don't have any money. My user hasn't given me any money to work with myself or any credentials for any payment methods, and I want to ask my user to pay for it. You can sort of pass that upstream. And that could hop between, just more than one agent if it needs to, until it eventually hits the user, who is interacting with this through some sort of UI, which we didn't quite draw a box for, but I'll do so now. And the UI would pop up, well, a payment box. Type in your credit card number, connect to your crypto wallet, whatever method is going to work in order to pay for the thing, then gets passed all the way back downstream to execute the transaction. On payments, I think this protocol can support really any payment method that exists, whether that's fiat or crypto. But we think this is going to be huge for adoption of crypto-based payment rails. For one main reason, like right now, if you're trying to buy something on the internet, like there are plenty of places where you can spend crypto, but it's always like we still haven't overcome those UX problems, and logistical problems. How am I going to get money into my crypto wallet? How am I going to do currency conversions? How am I going to on ramp? How is the merchant going to off ramp? These things are just getting in the way of crypto being used for payments day to day. It just, like, even for me, been in the crypto world for 10 years now, I still buy things with a credit card. But so when it's the human making the decision, like, they're reasonably incentivized to use fiat payment methods right now, unless they're very principled about it. But if this agent is talking to this agent and they're trying to negotiate on what payment method to use, in that case, are they really going to want to pass a credit card number over the wire? Or are they going to be a lot more incentivized to use a crypto-based payment rail? We think it's the latter. This is once agents are making these purchasing decisions on behalf of users, or at least recommending them to users, really changes the game as far as crypto adoption, just for everyday use cases. So we're building out, again, the open payment protocol. We're also building out a crypto-based payment rail on top of that protocol that we think is going to be particularly attuned to the needs of AI agents, to the needs of the system. For instance, we think, this discovery agent deserves a little affiliate revenue for introducing you to a service agent. We want to bake that into the protocol. We believe your UI deserves some affiliate revenue for getting you to the right assistant. If we build this right, this is going to incentivize more people to build discovery agents, more people to build service agents, more people to build UIs. And we don't want you to just have to connect to this thing through near.ai website. We want you to be able to connect to this ecosystem through any number of interfaces. And those interfaces should be incentivized to try to get you to connect to this ecosystem. Payments isn't the only thing you can get through here. The protocol for inter-agent communication, AITP, would require a few other things, for instance, credentials passing. But the more and more we put in there, the more and more it gets, it gets scary to do on the open internet, especially with LLM sitting behind here. If we're passing all this data, if everything we're doing involves a call out to ChatGPT's models to determine what to do next, then we've kind of lost the plot, and they can still sort of curate the internet for you and adjust what you do. Additionally, this assistant, in order for this assistant to be effective, it really has to be inside your brain. If you've ever worked with, well, the previous definition of an agent in the real world, a travel agent, a real estate agent, you hit that disconnect where it's hard to express. It's either really difficult to express your true preferences in plain language to it, or you just don't necessarily trust them. You're not going to tell them your entire life story, everything you've already ever done, everybody you're trying to contract with, and your true motivations. And so in order for this really to be effective, they're going to have to be really inside your brain, and you're going to have to trust that you can give them information and it's not going to get leaked, it's not going to get compromised, it's not going to be stolen. And that brings us to why we need trusted execution environments.
Sure.
Yeah, go for it. I've been talking.
Yeah. I'd use a marker. Yeah. Okay. So, as the internet is being revolutionized, people will want to be doing things that depend on their private information. So today, generally, even in the modern internet, the situation in which we are, where we have to share our information with entities that we have no reason to trust, is already a pretty bleak situation. It's going to get even worse, where effectively, if we envision this future where AI revolutionizes the way we interact with everything, it's one of the two futures. Either it's fully controlled by the same centralized entities we have today, right? So like Google, OpenAI, you name it, right? So you go talk to Google, and Google has a bunch of services, right? And so we continue giving all the information to a small number of entities that don't have your interests, that they optimize for, and right, or it's an open network of services. That's the future that is more desirable. But now, if you imagine all the services running on random hardware in the wild, it's one thing to give your private data to Google. It's another thing to give your private data to completely random people whom you don't know at all. You definitely have no reason to trust them. Luckily, there's a technology called Trusted Execution Environment, or T, that effectively says, you can imagine three entities here interacting, right? There's a user. I will draw him here again. That's a user. The user has some private information. Then there is a service. That's supposed to be a little cog. The service is a the service is a program, right? That is something that the user wants to do, and there's a service provider. There's a person who built it, who provides the service, and then there's the hardware. I will draw it bigger, because Illia from behind the scene is hinting me to do that, right? So that is running the service, right? And the service and the hardware, in many cases, that would be the same entity, but not always, right? Because we're moving to the world where hardware has to be GPU enabled with expensive GPUs. Not every service provider has to be necessarily an infrastructure provider, right? So ideally, the user wants neither the hardware provider nor the service provider to see their private data, and TEs enable them to do that, right? So TE effectively allows you in the environment. Do we have a green marker? No?
I got green, blue somewhere.
Yeah. Okay, so blue will be green, right? So red here means evil, right? So you can imagine that within this hardware controlled by an adversary, there's a vault that is such that user can verifiably confirm that everything that executes inside the vault, nobody can see what is happening in there, right? So it gives two big guarantees. Guarantee number one, it says, so user can inspect the program that the service provider provides, and the TE can guarantee that it is that program that is being executed, right? So the user knows that their data is processed in a very specific way. And the second guarantee is that nobody, not the hardware owner, not the service provider, can see what is happening inside of the TE, right? They cannot see the data, right? So this way, all those agents, discovery, like shopping agent, you name it, all the, like your psychotherapist, they all running travel agent inside of those TEs, right? And this way, a lot of people can provide interesting agents which require to see the private data to be useful. A lot of hardware providers can be hosting those agents, right? And users can be using them, being fully certain that their data is safe, and their data is used in a way that they want. Like it's not some sort of if they're sending it to a psychotherapist agent, they know the psychotherapist agent is actually trying to help them, not to upsell, future sessions, right? And here, coming back to Eric's point, ideally all of those, the hardware probably needs a little cut of the transaction, the service provider, right? And you would imagine it is possible that it's running on the hardware, like a CPU hardware, but then there's an inference server somewhere, etc. Right? Like thanks to the fact that with the payment channel, the payment the cost of the payment is effectively zero, right? You can have arbitrarily complex interactions of a large number of small components that all pay each other on the way. You can imagine even the networking part of it to have relays and whatnot that guarantee liveness, and they also get a little cut. And thanks to payment channels, all of those cuts combined still going to be less than 3% that you pay to Visa and MasterCard, right? So it's beauty.
Yeah, so maybe worth drawing the kind of this idea that effectively you have this service agents and your AI assistant, and so to service this securely, you have this cloud of compute providers, right? Which are combined, like some of them are GPU enabled, some of them are just potentially CPU. Although we're probably moving to a world where everything will be, one way or another, have accelerated mathematical coprocessors for AI inference. But you can have them effectively running the services, meaning they're hosted there. And you have, a layer as well on top that allows you to ensure that, if one of these nodes goes down, it kind of rebalances to another one. The workloads, there is kind of encryption and payments are managed through this. So this is kind of a concept of a TE cloud, which requires effectively a number of engineering challenges, right? Obviously the TE infrastructure, and we just with Fala released the kind of first version of an SDK to build, especially for GPU-enabled nodes, so you can actually have LLM inference in a private and verifiable way. The CPU, where you can run, the agent like business logic and kind of payment and routing and everything. There's another piece of work around kind of this payment channels and liveness guarantees. We've been calling proof of response, which enables to identify when nodes are not responding, them to actually lose some capital through slashing, and through that enable rebalancing as well. So there's kind of a whole system that's required to power this new internet in a private and verifiable way. Now, the interesting thing is, right, as we are actually going toward this direction, you have the idea that right now, if somebody builds a model,
Space.
yeah. So similarly, how with agents, right? Somebody builds an agent. They want two things. One, they want it to be discovered, and second, used, and they want to get paid, right? And so, discovery agent enables the discovery, hook it up into assistant, and kind of this AITP enables the payments for the usage. Now, it's the same thing is going about underlying models, right? Let's say I have some specialized data and I want to build an agent that uses the specialized data. So I fine tune a model kind of in a traditional way. Let's say I'm building, the most amazing therapist out there. And so now I have this model, and kind of traditionally you have two routes. One is you put it in a Hugging Face and effectively everybody's using it for free. Or you are running it yourself and building a whole kind of, all of this infrastructure yourself to offer a already final product or at least API to somebody else to do it. And again, we're getting into all the same problems, which is like, if you're running a therapist, it has access to your private data. Now you need to guarantee to me that you're not losing it, etc. And so this same infrastructure actually allows a few interesting things. Well, first of all, you can have the model you trained and you just upload encrypted weights that only decryptable inside TE. So what this allows you to do is now everyone, if somebody's building a therapist agent or even you doing this, you can just loop and use that model, and you have guarantees that only this agent is using this model, and you can monetize it. Or the model itself can charge for using through the GPU through part of this payment channel. Now, even one step beyond that, maybe, if you're a therapist yourself, you have a lot of knowledge about the space, but you probably don't have a GPU lying around to fine-tune the model. Well, you can actually fine-tune the model on private data directly inside TE, right? You can upload private data and say, hey, fine-tune this, the result will be kind of this encrypted weight model that then can be used in the system. So you're effectively getting to kind of this new way of effectively monetization for models. Now, one step further, right, you can pre-train a model in the same way, right? Right now, we have organizations, Meta, DeepSeek, who have done this pre-training, right? They spend a fair bit of money and they open source the model. And again, it's great, it's amazing, we can all use it. Only if we use their specific API, they're actually getting paid, right? Now, at the same time, it's actually not an open source model, it's open parameters model. I think we talked about this like in one of the first kind of office hours. There's only like few really truly open source models where you actually know what data went in. And even then, you cannot verify that actually data and these parameters are like correspond to each other. Like unless you literally retrain the model and you actually will get the different model anyway. So it's actually really hard to go like, hey, this is the data that went in, right? So so you have data logic that you train and you have weights. And right now you're effectively just getting weights, right? So we have open weights models. There's few examples of smaller models where people have posted data and code to train and weights, but you don't have like a proof that these weights are result of this. And if you train again, literally you will get the different weights because it's randomly initialized and you actually get different results. So what this TE infrastructure enables as well is actually the training itself can happen inside TE, right? And then you can have like a TE cluster or there's really interesting advancements around distributed training that's happening. And so now you actually have attestation that these weights were trained inside TE and that this data went into this and was reused on this code, right? So you can actually prove that these weights, for example, don't contain New York Times articles or that they contain some specific data. So it's a pretty kind of powerful way toward this user-owned AI concept where you actually know what's going on into your model and you actually can be confident that you don't have, sleeper agents, which is kind of a concept of, fine-tuning a model to react on specific inputs to give an output, which doesn't show up on any benchmarking, doesn't show up normally. But, when you plug it into your IDE, for example, and type in import, it will suggest, a specific library that has, malicious exploit. And so that would be one way to, through open ways to actually attack a whole host of code platforms. So this actually gives you kind of this open source model. Now, if you just, again, open up the weights, the problem is you don't have the way to monetize it, right? Everybody can use it for free, which is, again, great, but limiting because you cannot reinvest back to get better data, train a new model, maybe improve the logic, right? So what you can do now, again, you can have an encrypted weight model, which, again, only usable inside TE. And this way, whoever trained this can define the rules on how this model it can be used and how much they should be paid to do that. So, which again, this can be done by distributed community, this can be done through a token, or this can be done by some participant, who wants to add safety requirements, whatever that is, right? This can now effectively has some additional logic added to how these weights can be used. And so only usable inside this TE environment as well.
Just to accentuate that point, what right now when you deliver an open weight model, it's essentially a data file. Here's the weights. What an encrypted weight model would look like is essentially a run-up, like it's the data in an encrypted form, and also the program that you must run in order to run inference. You can download and run that locally if you have a GPU farm with that's TE enabled. But even on your own machine, you're not able to just decrypt and extract the weights. The only way to access it is through the program that wraps it, and enforces that you're running it on the TEE and decrypt the weights. This lets you do, and this is useful if your data set is closed. This is also useful if your data set is open. You could have a system where the input data and all the logic used to train it is open, but maybe the training is going to take 3 months and a few $1 million, and you want to recoup that investment. You could still have an encrypted weight model and make that make sense.
Yeah, or you're training it on, some biochemistry, for example, and you don't want it to be used to design weapons, so you add the logic to protect against that usage in this way as well.
Yeah,
but you still want to give it to students and to professionals to enhance their work.
Yeah, let's just put restrictions, but lets you put restrictions on your model without making it. You have to hide behind a centralized API. You have to run that all the infrastructure yourself. You could still run it yourself, but it doesn't make it a necessity.
Yeah, so all of this effectively kind of becomes a stack that we are working with a lot of partners to build. So obviously, this is a lot of infrastructure and a lot of kind of logic and things to build. So NearAI is a pretty small team. So we are working with a lot of partners to actually make this happen. Right. So T infrastructure, as I said, working with Fala to enable this. We have partners who helping with the proof of response for the liveness guarantees and kind of some of the payment channel infrastructure that we're going to be releasing soon. We have kind of the protocol that we're going to be releasing. Then that we want to welcome other people to build variety of services agents and especially discovery and service agents to build on top. And obviously this AI assistance, we're going to have a prototype, kind of a MVP of this, but we want to open it up for everyone to participate. And so kind of we want to welcome everyone to really contribute to this because, again, as Eric mentioned, this is a future that's happening. It's inevitable, kind of how the world was restructured around AI being the facilitator of your kind of interactions. And it's now really about kind of the open protocols, and open ecosystem to win over, one of the closed ecosystems to actually, deliver all this without privacy, without kind of opportunity for other people to participate.
Yeah, and we're not just doing this. We're not just asking everybody to contribute to this ecosystem as a favor. We're trying to make sure that there's incentive structures in place in order to create this open ecosystem, this new internet, and do it in a way that's going to be natural. So with building these service agents, that should be a good business. That's your apps of the future. Building a discovery agent, that's Google of the future. That's App Store of the future. Building an assistant, these are all things that are going to be financially rewarding and good for the world, good for your users. Similarly, over on the model training side, with encrypted weights models and with the payment channels, you can monetize those models. That means that you can have code within the download, code within the model that enforces that you are paying per usage. And that can go right back to the model developer, to anybody who's contributing data, anybody who's contributing logic. It really makes it so that if you feel like open models or even locally run models are important, you don't have to just give away all your work. The incredibly powerful concept that we think can sort of naturally incentivize the creation of this new open internet, which I think brings us to model training. Okay.
Wait. You got more training?
I don't know how much deeper we can dive here. I guess everybody by now knows we cannot see ourselves anymore, but that's chill. Everybody by now has seen, DeepSeek. We had a reading group yesterday, right? So we still a week ago, yes, right, a week ago, and so we still live in this beautiful present where entities still have an incentive to throw away millions of dollars to train a model and publish it, right, for the secondary effects. But that will not necessarily last, right? And so for open source community to continue. So to have a certainty that open source community will continue being competitive with the closed source, you need, first of all, we need expertise in the wild, how to train those models, right? So it's great that DeepSeek and Meta can do that, but it would be great if we have open available knowledge how to train those models, right? So that's something interesting that we're working towards. And as Eric mentioned, you do need to be able to monetize those models, right? So it's one thing for us to be able to train a model that is competitive with the closed source. It's another thing that we need to have an incentive to do that, right? So this whole infrastructure with being able to train an encrypted model, so I guess there are several interesting aspects of it here, which get progressively more and more interesting, right? So first, I guess, is imagine you have an entity, right? So you are an entity which has expertise to train the model. You want that model to be monetizable, but you want it to be open source, right? I guess it could be because you have values, like it's against your values to publish a model that is not open source, or it might be that you are an entrepreneur. You don't care about the world, but publishing it as an open source gives you recognition in the community, right? So in this case, you have your own hardware. You don't need to train it in an encrypted way, right? So you have like your cluster of H100s, or that cluster could be hosted elsewhere, right? Like on exhibits or hyperbolic or you name it, but they're running inside of the TEs, right? So your model is not encrypted for you, meaning that you have the weights, but while it is being trained, it is trained in an encrypted fashion. So the actual providers of the hardware do not see your model as you train it, but after it is trained, you have the weights. You can host it on your API, or you can host it inside of the TEs with payment channels for everybody, right? But then you can go one level deeper and say, well, instead of having that single entity, we have a sort of a DAO, right? So if you envision training, it is hard to tell right now if the models will continue growing, right? But if you envision that you have to train models which are significantly bigger than the existing ones, it could be that no single entity in the open community is capable of having resources to train it, right? Then you can envision a sort of a smart contract which accumulates resources from multiple entities, right? Pulls resources from the decentralized providers, and then it trains a model that is encrypted, meaning that nobody has the weights, right? So no single entity can run away with the model, right? And screw everybody else over who participated. The model exists only in the encrypted fashion. Not a single entity in the world can decrypt it, right? But that model comes with a virtual machine runner that can run inside of the TEs that will be able to decrypt it within the TE, right? So still nobody outside of the TE can see it, right? And it would only run inference for you if you pay via the payment channel, and that money gets distributed back to the original smart contract, right? Or something like this, right? Or like, Illia has some other ideas. I don't know if he wants to share them in terms of how it can be monetized, right? But the idea here is that you can have now a massive decentralized effort where a large set of people contribute resources, ideas, and data, right? And then it trains a model, on the pooled resources, and that model is a community, is a common good, which pays back everybody who participated.
Yeah, I mean, maybe to add to this actually, because one of there's kind of combination of challenges of training, state-of-the-art model. The big one is always been like how to kind of curate data, even that kind of the base data set is available. It's just internet, and there is available crawls for people to use, but it's mostly low quality. So you do need to actually filter it down to a high quality data that model would be able to train on, and that in itself, requires kind of a fair bit of engineering that it needs to be done. And right now, this engineering is done inside, Meta and OpenAI and Google and DeepSeek, but it's not actually done in open source, and there's no way to there's no way to just pick up from the kind of shelf a good solution for that. And one of the challenges here is that nobody has like a good motivation to do that, because if you do build such a good data set, like you're not going to benefit from that, and it does require a lot of work to carefully curate it, potentially run a smaller model on top of the data to filter it out, etc. And so again, using this T infrastructure, we can actually have a system where somebody can curate, somebody can build different data filtering procedures and submit them to run inside TE. So the filtering itself happens kind of privately. The outcome is private, and this outcome of a data that then later used, again, requires a payment, right? So like whoever then later wants to train on top of this outcome needs to pay to whoever creates data, right? So effectively every artifact through the process of training is now monetizable, and you can create a system around it. Now, one of the ways to monetize in general in crypto is launch a token, right? And so even small artifacts like this, where you effectively took, for example, all of a common crawl, can be, you can have a token for this specific data filtering, and then you require that, like, you attach to this artifact some logic and say, if you're going to use my data for training, you need to, for example, burn a bunch of my token, just as an example, right? So you have like all of this kind of additional logic now that you can attach to any intermediate artifact and the whole process as a whole. And so indeed, you can have a DAO that kind of collects dollars and gives the like model token. You can almost imagine this like initial model offering, and then it spends its dollars on GPU, maybe on data processing, maybe on indeed like knowledge and expertise of specialists who actually code it up, and then it can receive the payments, right, which presumably are in dollars or near, from this model being used in production through the whole system, as well as independently if somebody just wants to use the model for their own use case. And it can decide to distribute it to the model token, or burn it, or reinvest maybe into next one, so this model token just becomes actually a model series. So this can be O can stand for open, so it's a DAO AI, so decentralized, autonomous, open AI system. So again, this is just examples of what you can build on top of this infrastructure, and kind of the ways to build this. And so again, the idea here is that we want to partner to enable this kind of use cases and findings, both specialists as well as building out some of the learning education for kind of people who just come into the space. As there's more and more people interested in how to do this, to really enable this kind of community built and entrepreneur built systems with monetization, which then flow back into this whole new internet of kind of AI first assistance. So yeah, if you're in model building or interested, join us here. If you're already building models and interested in how to monetize them, join us in TD Cloud. If you are running a service or planning to build a service, join us in building effectively AI agents for the services. If you are really interested in how to solve the discovery problem, we want to talk to you. If you're really excited about how to build the best assistant in the world, join us. And if you're running an application that it has users and growing, and you are interested in how to introduce this new internet to your users and effectively enable your application to become a super app, this is where all of this infrastructure comes together and really plugs into your application. And you actually get a lot of this for free, because it is monetized through the transactions in the process, not by paying $20 a month.
You want to redo it without Siren?
Was Siren heard? I don't know. On the mic? Oh.
Jared, if you're listening, have you heard the Siren? Like in the last meetup? Okay, sounds great.
All right. Anything else we should add?
No, I think that's a great finish.
That's good.
All right.
And just say like, thank you guys.
All right. Well, on this, we're going to finish this session. Join us for, we have this every week. Either we're talking with projects or we're partnering on different angles, projects that are doing really cool stuff, or learn more about what we're working on. And follow @near_AI for more news.